Hi, I'm Hemse Salix, and this is my Dsari Project. Background: I live in Territorial Hall in a double dorm, approximately 189 square feet. There are two residents. Minimal time is spent in the dorm. Roommate prefers the lights are off. According to the average provided by a source on my final slide, a room of 189 square feet should use about 3,572.1 kilowatt hours annually. I defaulted to an average as U of M doesn't make dorm power usage public. The top right is a table I believe accurately describes the typical energy use of a room, similar to mine. I also made a table utilizing many sources to calculate the average annual energy use for my devices located in the bottom left. These are photos of me recording wattage or kilowatt uh, hours of each device. These are some more. For the overhead lights, I couldn't access them, nor was I even tall enough to attempt, so I asked the front desk uh, what it was, and they told me it was 60 watts. For almost every device, I left sticky notes around daily to log use. My roommate also helped log when the lights were off and when they're on. I then put all this data into a notebook before organizing everything into a spreadsheet. For my iPhone, I use the screen time app bundle for iOS and record the screen time at the end of the day. Device type, I had a lot of variable devices, and I only had two constants, but I made sure to at least have more than one. How to calculate energy use for different device types. For variable device types, use a kilowatt to measure how much kilowatt hours you would use during a typical time frame. To get the average power consumption, divide the total hours by how long you measured for. For example, I measured that my fridge used 1.07 kilowatt hours after 21.34 hours, meaning the average watts used during that time frame is 1.07 divided by 21.34 kilowatt watts, which equals 50.14 watts. Find the average energy used each day. You just multiply the average watts by 24. So, for example, 24 hours times 50.14 watts equals 1.2 watt hours each day. For lights, for overhead pre-installed lights, you log when your lights are on and when they are off, and learn the wattage they use, or assume 20 watts as detailed in the rubric. To calculate how much energy is used by the light, you multiply the measured time on and assumed wattage. For example, I use my light for 19.87 hours throughout the week, so to calculate how much energy was used during the week, you just multiply the two values. Having overhead lights that use 60 watts, I can solve for the energy used per week by multiplying time and power. 90.87 hours times 60 watts equals 1.19 kilowatt hours each week. You can divide that by 7 to get each day. Constant devices. Use your kilowatt meter in order to measure its constant wattage while on. Next, turn the device off and measure its phantom wattage. Multiply the watts used while on by the durations on, and multiply the watts while off by durations off. For example, my lamp uses 0 watts when off and 4.8 when on. It was on for 6.32 hours during the week. And the week is spent 6.32 times 4.8 divided by 1000 kilowatt hours, which equals 0.03 kilowatt hours. This is my complete audit. Think I'm very thankful for the pre-made format as I inputted all my data and it had calculated everything for me, saving a large amount of time. What I noticed that my measured kilowatt hours for my cat opener and my calculator was 0. I believe this is due to their power consumption being significantly small on standby. Perhaps if I measured for 24 hours, I may have gotten a result comparable to the general averages. I also noticed that I hadn't actually used my can opener. I've been so busy, I haven't popped open a snack in a while. The power usage was also significantly lower than I expected. My habits have definitely changed since going to college. Comparison of total energy measurements. The table in the top left details my average power consumption for a category each day in kilowatt hours, while the table in the top right shows the average power consumption for a category of an individual living in a residence of similar size. I have every category but refrigeration unique. As we can observe, the average annual energy use value significantly my behavior this week reflect all others in the year. I was only beaten in two categories. The first is the energy my laptop consumes, which makes sense since it's a gaming laptop with a bunch of settings to preserve battery life. The second is the energy use of my fridge. My energy use is significantly higher, which makes sense as I intentionally lowered the temperature and leading to increased power consumption. The first method that comes to mind is underclocking my laptop in order to use less power passively. This could potentially decrease my energy use by 1% depending on how low I set my clock speed to. I could get rid of my lamp in order to reduce my energy use by 0.2%, 1.5, as shown by the calculation, and 662.21 kilowatts is the total amount of energy used annually. I could get rid of my Nintendo Switch as I don't really use it. This could potentially decrease my energy consumption by 0.55%, as shown by the calculation. These are my sources. I use nearly every single one, and I read every single one.